So I will also show you a problem on using both decimation in time and decimation in frequency for a 4-point problem. Okay, so the problem is like this. Okay, given the sequence x1 of n and x2 of n, compute the circular convolution x1 of n, circular convolution symbol, x2 of n, for n is equal to 2. Use DIT FFT algorithm is the first sub question. Second sub question, use DIF FFT algorithm. So using both decimation in time and decimation in frequency, we are going to solve this problem. Okay, so you can see the values of x1 of n and x2 of n. So if you want to perform the circular convolution using DIT FFT and DIF FFT, it means that you have to have your x1 of n, have your x2 of n, find out the FFT of this. What will be the output of this? X of k, that is x1 of k. Find the FFT of this, you get your x2 of k. Okay, then you got to multiply both to get your y of k, and you perform your IFFT of the sequence y of n. Alright, this is what we are going to do. So first thing we will do is find the 4-point FFT or the 4-point DFT using the FFT algorithm. First we'll take decimation in time FFT algorithm. We'll find it, we'll multiply the answers, and then you use the same butterfly structure to find the IFFT. Only difference in IFFT is that IFFT or the inverse Fourier transform, only difference will be your twiddle factor will have negative power. That's all. Whether it is DIT FFT or DIF FFT, the butterfly structure remains the same. Only thing is, wherever if you want to find the inverse Fourier transform using the FFT radix 2 algorithm, okay, then you will have to use negative powers for your twiddle factor. That's it. So first let us draw the butterfly structure. Okay, let me draw the butterfly structure. So in case of DIT, you will have the, how is the structure? You will have the 2-point butterfly first, followed by the 4-point butterfly. In case of 8-point, you had 2-point, 4-point and the 8-point. So since it is just a 4-point FFT using DIT, so in DIT, remember, input is bit reversed. Okay, so we are going to solve this problem in that way. First thing, draw the butterfly structure here. So since it's lines are already there, took a ruled sheet because of that. It's easier to show you, and just 4 points. So draw your 2-point butterfly structure first. Okay, so the twiddle factor you're going to use is W4. So here it is same as, all you have is, you have a -1 and this is your W2 bar 0, which is same as W4 bar 0. Okay, W4 bar 0 is nothing but 1. You have this, followed by your 4-point butterfly. Okay, this is your 4-point butterfly. Having your W4 bar 0 and W4 bar 1. You know the twiddle factor values, you can write down in the side. Bar 0 is 1. This is -j. So you have -j here. Okay, this is your structure. So the inputs is in the bit reversed order. If you have a doubt, even that also you can write it in the side. 0 0 0 0 0 1 0 1 0 0 1 1, right? These are the values. So you read it in the bit reversed order. At the 0th location it is 0. This will be, so this was for taking 3 bits was for 8-point, right? 0 4 2 and 6. This was the even numbered sequence you had for 8-point. So for a 4-point sequence, okay, this is 2 power 2. Okay, so how many bits you have to consider? You just have to consider 2 bits, 0 0 0 1 1 0 1 1. This is your 0 1 2 and 3. Okay, so at the 0th position you read it in a bit reversed way. Bit reversed would be 0 0 1 0 0 1 1 1. So this is nothing but 0 2 1 and 3. So this is the bit reversed order. Instead of 0 1 2 3, 0 2 1 3. So I write, that means I have to write x1 of 0. You write it in another pen, you will understand better. This is x1 of 0, x1 of 2, okay, and this is x1 of 1, this is x1 of 3. So give the inputs. The first input is 2 1 1 2. So you write the inputs 2 1 1 and 2. The inputs are given in this order. So remember this, okay? Since it's a 4-point, the bit reversed order is this. For an 8-point, we used to calculate it this way. We use 3 bits for 8-point because 8 is nothing but 2 power 3. That is why this is called as radix 2. Okay, that is why it is called as radix 2 algorithm. Alright, so this is it. This is your structure. Now keep doing it. So this is 2 plus 1. You get 3. Again 2 comes here. 1 into -1 is -1. 2 minus 1 is 1. Again 2 plus 1 is 3. This is 1 minus 2 is -1. So this is what I have at stage 2. Stage 3, what do I have? At this point, I will add this value 3 plus 3, that is 6. At this point, I add 1 plus -1 into minus j, that is plus j. So I will get 1 plus j at this point. At this point, what do I get? 3 minus 3, that is 0. Okay, here minus 1 into minus j. Okay, that is plus j. But again you have a minus 1 here. Minus 1 into minus j plus j into minus 1 minus j. So what do I have from here? So it is 1 plus j. Sorry, 1 minus j. You got this? Let me explain. This is 1 plus whatever is coming here. What is coming over here? Minus 1 into this minus j I have, into this minus 1. So minus 1 into minus j I got plus j. Plus j into minus 1 is again minus j. So this is this 1 minus j. So this is whatever answer I am getting, right? x1 of k. So these values 6, 1, 1 plus j, 0 and 1 minus j. All these values, this is x1 of k that I got. Okay. So the next we take x2 of n, and even for x2 of n we try to find our x2 of k using DIT FFT radix 2 algorithm. So in many questions you may find this radix 2 algorithm, and then they may say DIT or DIF. You must be very careful. Or sometimes in the question paper they may just mention to you radix 2 algorithm. So why this is called as radix 2? I told you in the earlier classes, the butterfly structure is basically having 4-point butterfly, 2-point butterfly and 8-point butterfly and so on. So these are powers of 2. So here, since the value of n is 4, which is nothing but 2 power 2, okay, this is radix 2. Radix 2, the base is 2, right? 4 is nothing but 2 power 2. Whenever your n value is multiples or has got powers of 2, you can always use this radix 2 algorithm. That is the meaning. Alright. So since 4, you can write it as 2 power 2. If it was 8, I told you, if it was 8, you write it as 2 power 3. So you have 3 butterfly structures, 3 set of butterflies. That is 2 point, 4 point and 8 point. So here, since it is 2, you have just 2 butterfly structures. That is the meaning. Okay. So the bit reversal, I will, since it is 2 power 2, I will have only based on the power. Since the power is 2, we have just 2 bits for the indexing. So 0th bit is 0 0, 0 1, 1 0, 1 1 is the binary bit reversal. I'm just explaining to you that again. So you reverse the bits 0 1 2 3, because in input you need to give it in the reverse order. So bit reversed value is, you read like this. This is 1 0, 0 1, 1 1 1. So this is 0. This is 1 0 is 2, 0 1 is 1 and 3. That means 0th, I need to write the inputs. In case of DIT, the input is bit reversed. Right? So what I'm going to do, let me draw the butterfly structure again for x2 of k. To calculate x2 of k, 1, 2, okay, 3 and 4. Okay. So I draw the 2-point butterfly. Alright. And again I draw my 4-point butterfly structure. This is minus 1, minus 1, minus 1, minus 1. And in the earlier cases, you remember the input that you're going to give here is W4 power 0, which is nothing but 1 itself. but it's mandatory to write it. This is the butterfly structure here, and here we have our W4 power 0 and W4 power 1, and the input, as I told you, I'll be feeding it in the order, in the bit reversed order, 0 to 1 3. That means x of 0, x of 2, x of 1 and x of 3. 0, 1, 2, 3. In that order I will write it. So what is the second sequence? 1 minus 1 minus 1 1. Right? 1 minus 1, okay, minus 1 1. All right. So now let us perform the operation. Okay, so this is at this point, what am I having? 1 plus minus 1, that is 0. Okay, at this point I am having minus 1 into minus 1, that is plus 1. 1 plus 1, that is 2. Okay, again here plus 1 is coming over here across this arrow, and minus 1 from here across this arrow. This is minus 1 plus 1, this is 0. Again minus 1, 1 into minus 1 is minus 1. So minus 1 plus minus 1 is minus 2. Okay. Now the fourth stage, the 4-point stage, W4 power 1, you know, is minus j. So keep this with you. Draw the arrow marks. Okay. All these values going like this. Okay. So 0, having it here, 0 at this point, plus whatever is coming here, 0 plus 0 is 0. This is 2 plus minus 2, okay, 2 plus minus 2 into minus j, this is plus 2j. So this value is 2 plus 2j. I hope you got it. See, this is 2 plus minus 2 into minus j is minus 2j, plus 2j, sorry, minus 2 into minus j is minus into minus plus. So plus 2j goes here, plus 2 comes here, 2 plus 2j. What comes at this point? Right, from this arrow you get the 0 here, plus 0, so this is 0. So here at this point you're going to get 2 plus minus 2 into minus j is plus 2j. This plus 2j into minus 1 is again minus 2j. So this plus 2 minus 2j. Okay. So this is about your 4-point butterfly. So since the problem is asked for doing your convolution, we had x1 of k and x2 of k. We will multiply the values element by element. Okay. So let me rewrite x1 of k. What did we get in the x1 of k? x1 of k was 6, 1 plus j, comma 0, comma 1 minus j. Okay, into x2 of k you got now, sorry, 0, 2 plus 2j, 0, 2 minus 2j. Okay, now multiply both. Okay, you get 6 into 0 is 0. 1 plus j into 2 plus j, you can do it here. The bottom, 1 plus j into 2 plus j, what is it? This is 2 plus j into 2 is 2j, j square is minus 1. So this is 2j plus j is 3j, 2 minus 1 is 1. So this is 1 plus 3j, right? Sorry, this was 1 plus j and 2 plus 2j. I just wrote only 2 plus j. So 2 plus 2j. So this is 1 into 2 plus 2j is 2 plus 2j, j into 2 is 2j, j into 2j is minus 2, j square minus 1 minus 2. So minus 2 plus 2 minus 2 0, you are left with 4j. So second sample is 4j. Third, 0 into 0 is 0, and let us do, okay, calculations I'll show here. 1 minus j into 2 minus j into 2 minus 2j. So what is that? This is 2 minus 2j, minus j into 2 is minus 2j, minus j into minus is minus into minus plus, plus 2j square. This is plus 2j square means it is 2 into minus 1 j square. So 2 minus 2 goes, you are left with minus 4j. So this is minus 4j. So this is your x1 of k into x2 of k. Right? This is the answer for x1 of k into x2 of k. So you call this as y of k, which is x1 of k into x2 of k. Okay. Now what do you have to do? What do you have to do? According to this diagram, see, we found x1 of n, x2 of n. We found using DIT, we found x1 of k, x2 of k. We got y of k. Now we need to find IFFT. So IFFT also you're going to use decimation in time, that is inverse DFT. Let me show you how to do the inverse DFT using the same butterfly structure and the same concept. Only thing is your W4, your twiddle factor. See, the only difference in case of your inverse FFT is that, okay, you will have a 1 by n term. Okay, if you write your IDFT equation, what is your IDFT equation? You want your x of n is nothing but summation k varies from 0 to n minus 1 x of k wn per minus nk. So the main thing here would be your twiddle factor, right? The twiddle factor, you will use your negative power. So instead of wherever you have W4, okay, an important thing here over here is your 1 by n. Another important thing. So two things that you need to concentrate. One is this and one more is this. Your twiddle factor and your 1 by n. So these two things you consider, and we will use the same butterfly structure. We'll use the concept of the same bit reversal. We give the inputs in the same bit reversed order. Okay. So how do I do that? How do I do that? Let me draw the butterfly structure for IDFT or IFFT, I can call it. IFFT using DIT. Okay. Alright, so again I have x of k as input now. X of k I have got from the answer. I have got what? 0, 4j, 0 minus 4j. This is the x of k that I have got here. After the calculation, after multiplication, this is the, sorry, y of k. You write it as y of k, no problem. Y of k. Which was nothing but x1 of k into x2 of k. So your equation, instead of x of n, customized to this, you can say that you are actually finding out y of n here. Okay, for this problem, y of n is 1 by 4 summation k equal to 0 to 3 y of k w4 per minus n into k. Okay, here your n varies from 0, 1, 2, 3. So this is what you are actually finding out using the FFT structure. So input for DIT, you know, input is bit reversed, right? Input is bit reversed. So I will feed y of 0. You can see here y of 0, y of 2, y of 1, y of 3. So first I'll give y of 0, y of 2, y of 1 and y of 3. Let me feed in the inputs. It is 0, 4j, 0, minus 4j. So it is 0 plus 4j, 0 minus 4j. Okay, these are the inputs. Now let's draw the butterfly structure. So here it's important to write down, this is W4 par 0, minus 0 actually. Okay, there is nothing as minus 0. Okay, here also it is actually W4 par minus 0, which is actually W2 par minus 0. Same as minus 0, same, right? Because this minus is because of this term in your expression. Alright, so this is it. This is minus 1 as usual. And again here your 4-point butterfly structure with minus 1, minus 1. So here you should see that we have W4 par minus 0, W4 par, instead of plus 1, it will be minus 1. Okay. Is it clear? I hope it is clear. Alright. So, we all know W4 par minus 1 is nothing but J. Okay. So, we go on next. Let us solve this step by step. 0 plus 0. And remember, when it is IFFT, here we will have we'll divide whatever answer we get by 1 by 4 at each stage because of this term. Okay. Alright. Got this? So have a look. Now let's solve this. So 0 plus 0, at this point I get 0. Here it is 0. Minus 0, I get 0 again. Okay. Here it is plus 4j. Minus 4j, I get 0. Plus 4j. Minus 4j into minus 1, that is plus 4j. 4j plus 4j, I get 8j. So at all these points, what am I going to get? This is 0. 0 plus 0 into, this is nothing but 1. W4 par minus 0 or plus 0 is same. 0. 0 plus 8j. Okay. 0 plus this 8j term into j. J into j is j square minus 1. So this is 8 into minus 1 minus 8. So this is minus 8. Here it is minus 8. What about here? At this point, okay, I'm having this value here. So this is 0 plus 0, 0. Again, this also, there is 0 coming in here. 8j into j square minus 1 minus 8. Minus 8 into minus 1 is plus 8. Okay, this is plus 8. Now divide all this by 1 by 4. This is the final x of n value. What is it? 0 divided by 1 by 4 is 0. Minus 8 into 1 by 4 is what? Minus 2. 0 into 1 by 4 is 0. 8 into 1 by 4 is 2. So the final y of n is 0, minus 2, 0, 2. Alright, so this is the convolved answer. So basically, even in the exam, they could simply give you a sequence and ask you to find the IFFT using DIT or DIF method. Or they could give you a problem like this. A 4-point sequence is given to you and they ask you to find a 4-point DFT of the sequence using DIT FFT radix 2 algorithm, or DIF also could be used. We'll solve the same problem using DIF also. Okay, so have a look. This was a question. Sequence x1 and x2 is given, DIT and DIF. So we have done the first method, that is first one using DIT FFT radix 2. Okay, we have done using this. All right, hope you have understood. So this was the question. Find the circular convolution using DFT IDFT method. Using DIT means this is what you have to find DFT using not equation method, not matrix method, using the FFT radix 2 algorithm. Which algorithm? First we have used DIT FFT algorithm and we have solved. So take each sequence, input the value in bit reversed order. So for the, since it's a totally a 4-point, you will consider 2 power 2 values. Okay, you will consider 2 power 2 values. 2 power 2 means totally you have to consider 2 bits. Raise whatever is the power, that many bits you write it. Write the binary value. Bit reversed value is 0, 2, 1, 3. So in this order you need to give the input. That means x of 0, x of 2, x of 1, x of 3 you need to feed your input. Okay, if it was 8-point, what did we do? We used 3 bits, 2 power 3 bits, and we reversed it in that order, 0, 0, 0. That means first I input 0th sequence, then I input, instead of first sequence I'll write 4th sequence I'll input. So remember, in your DIT FFT we are giving the input in the bit reversed order and getting the output in the same order. So this is your x1 of 0, x2 of 0, sorry, x1 of 1, this is x1 of 2, and this is x1 of 3. Okay, so this was x1 of n, we found x1 of k. Similarly, x2 of n, we found x2 of k for the second sequence. Okay, for x2 of n, we found again the radix 2 algorithm. Use input the sequence 0, 2, 1, 3, feed it, do the calculation, get it, multiply x1 and x2, you get y of k. Okay, this is your y of k, and then perform IDFT also using same thing. Only thing change in IDFT is the twiddle factors will have negative powers and a 1 by n term. In our case n is 4, so 1 by 4 term comes. Rest all the calculations are same. So you got your y of n, which is the final convolved output of your x1 of n and x2 of n. So convolution in time domain, you have converted to multiplication in frequency domain. How did you do that multiplication? Using DIT FFT. Just to elaborate to you how to do this butterfly structure problem, I have taken this problem. Okay. So individually, they may just give you one sample and ask you to do FFT or IFFT. Or they may give a full-fledged problem like this. Using decimation in time, perform the convolution of this sequence. Okay. Now we'll also do using decimation in. So using decimation in frequency, we can perform the same operation. Again, we find x1 of k, x2 of k, and then multiply and take IFFT using DIF FFT radix 2 algorithm. So if you have a look, the basic butterfly structure for your DIT FFT is like this: A, B, and the W and twiddle factor you have before. You have the -1, 2-point structure I'm showing. It extends for the 4-point and 8-point. So you have the twiddle factor before, -1, and the terms are like this. If you have A and B, it will be A plus B into Wn per r. It will be A minus B Wn per r. Okay. Whereas the structure, basic butterfly for DIF is like this. Your twiddle factor comes later. A minus p into wn power r. This is a plus b. That's it. Okay, this is your structure, butterfly structure, basic butterfly. So in case of your DIF FFT, we'll have the higher point FFT first, followed by the lower point FFT. So here the input is given in the same order, that is x of 0, x of 1, x of 2, x of 3. That is in the same order. I have 2, 1, 1, 2 as the input. So you have minus 1, alright, followed by, here you will have your W4 power 0, W4 power 1. So what do I get across these points? Here I have 2 plus 1, that is 3. Here I have 1 plus 2, that is 3. And at this point I have this 2 plus 1 into minus 1 is minus 1. So 2 minus 1 is 1. 1 into W4 power 0 is 1. W4 power 1 is minus j, remember. Okay. So 1 plus 2 into minus 1 is minus 2. Minus 2 plus 1. 1 minus 2 is minus 1. Minus 1 minus j is plus j. Okay, so these are the values I get. Alright, now let me see your 2-point butterfly you can draw. Okay, this would be minus 1, minus 1, W4 power 0, W4 power 0. So this is 3 plus 3, that is 6. So this is 3 minus 3, that is 0. This is 1 plus 2. Sorry, this is 1 plus j. And here you have this 1 plus j into minus 1. Plus j into minus 1 is minus j. So this is 1 minus j. Now remember, in case of DIF FFT, the output is bit reversed. Input is in the same order. Output is bit reversed. Bit reversed means, so this value is x of 0. So this is what I get. Okay, if I rewrite this answer in the same order, it is 6, 1 plus j, 0, 1 minus j. Okay, so was this the same answer we got? See, using decimation in time also, x1 of k, we got the same answer. Okay, so using decimation in frequency also we got it, but the values you see is bit reversed. 6, 1 plus j, 0, 1 minus j. X of 0, x of 1, x of 2, x of 3. Okay, so let us write it here. X1 of k, whatever we got is 6, 1 plus j, 0, 1 minus j. So the same answer what we earlier got. 6, 1 plus j, 0, 1 minus j. Okay, similarly let us do x2 of k also using DIF FFT. Let us draw the structure. So we feed in the input for x2 of k also in the same order. Alright, and we just try to get the answers. Just do it along with me. 1 plus 1 minus 1 is 0. Minus 1 plus 1 is again 0. Here at this point, what do we get? This is plus 1. Minus 1 into minus 1 is plus 1. Okay. So this is plus 1 plus 1. So we get 2. Here it is minus 1. 1 into minus 1 is minus 1. Minus 1 minus 1. Minus 2. Minus 2 into minus j. So this is plus 2j. So across the stage 2 you get 0, 0, 2 plus 2j. Now keep adding these. 0 plus 0, 0. Here you actually have W4 plus 0. 0 plus 0, 0. 0 minus 0 is 0. Plus 2 plus 2j. This one is plus 2. 2j to minus 1. 2 minus 2j. So this is your x of 0. This is x of 1. And this is x of 2. And this is x of 3. 0, 2, 1, 3. Bit reversed. Output is bit reversed because it is DIF FFT. So you write your x2 of k properly in the proper order. So it is 0, 2 plus 2j, 0, 2 minus 2j. So you can see this is the same answer we got using your DIT FFT also. Your x2 of k values were the same. See, 0, 2 plus 2j, 0, 2 minus 2j. These were the values you got, but here it is in the same order. You can see your x2 of k, whereas in case of DIF FFT, you can see it is bit reversed in nature. Okay, but the answer you write it in the same order. So you got the same answer. Again, your y of k remains the same as x1 of k into x2 of k. You multiply your 6, 1 plus j, 0, 1 minus j into 0, 2 plus 2j, 0, 2 minus 2j. The calculations remain the same. Alright, the calculations remain the same. We had done it. Multiplication of these element by element. 1 plus j into 2 plus 2j and 1 minus j into 2 minus 2j we had solved. So your y of k, that is x1 of k into x2 of k, y of k answer remains the same. You get, if you multiply this, you're going to get 0, 4j, 0 minus 4j. Okay, you got this. Now IFFT using this particular method. So let us draw the diagram for that first. Butterfly diagram for your 8-point IFFT using DIF. How to do 8-point IFFT? Again, draw a butterfly structure. So for the IFFT, this is the basic butterfly diagram. Okay. So the input, your 4-point butterfly with -1, W4 power 0, W4 power -1, W4 power 0 for the 2-point structure, and followed by, remember, your 1 by n, because this is IFFT or basically your IDFT using your radix to DIF FFT radix 2 algorithm. So here the input is in the same order, capital X of capital Y of 0, Y of 1, Y of 2, Y of 3. This one you're going to input in the same order, 0. Here it is 4j, 0, minus 4j, and I'm sorry about this line. Okay. Add these. 0 plus 0 is 0. 0 plus is 0. Plus 4j from here. And minus 4j. 0. 0 plus 0. Again you get 0. So this one is plus 4j. Minus 4j into minus 1 is plus 4j. 4j plus 4j is 8j. 8j into j. J square is minus 1. So this is minus 8. Okay. Now go on adding. 0 plus 0 is 0. 0 minus 0 is 0. Minus 8 plus 0 is minus 8. 0. Minus 8 into minus 1 is plus 8. So this is plus 8. Have these values. Now do this multiplication with 1 by 4 or nothing but you're dividing these values. So what do you get? 0 by 4 is 0. 0 by 4 is 0. Minus 8 by 4 is minus 2. This is 8 by 4 is plus 2. So we know the output is bit reversed, that this is okay your small y of 0, this is y of 2, this is y of 1, this is y of 3. 0, 1, 2, 3. So your y of n, actual y of n answer is nothing but 0, minus 2, 0, plus 2. Minus 2, 0, plus 2. Which is the same answer we got using the previous method also. Which is the same answer we got using DIT FFT also. You can see this was the answer we got in decimation in time also. Right? So this was it, what we did. Using both the methods we have done the problem. We have so many times we have computed your 4-point butterfly values and everything. Okay, I hope you have understood. Thank you.